Hello guys, how are you? Hope you are doing good. Let's get back to the lecture on applied probability and statistics. So in this lecture we will discuss two continuous probability distributions. So for now we have discussed numerous discrete probability distribution. In this we are going to discuss two continuous probability distribution, that is uniform distribution and normal distribution. So yeah, uniform distribution. So uniform distribution is a very important distribution, and more so because all the other distribution data can be generated using this distribution. Okay, so first let's know what it is. So this is a random variable x, and it takes any random value between two parameters like a and b. Okay, for example, it will take any random value from 0 to 1. So we don't know which value it will take, but it will take anything between 0 and 1. Okay, another thing is all the values are equally likely, because that is all are equally probable to occur. Okay, so let's come back to the what is the application of this. So focus on this figure. Okay, focus on this figure. You must have played like a game like this on Amazon or Cred. Okay, this is nothing but a spinner. So this spinner can be rotated from 0 to 360 degree. Okay, so basically once I spin this spinner, it will either land in this region, anywhere from 0 to 360 degree. So I can say that the spinner is nothing but a uniform distribution taking values from 0 to 360 degrees. Okay, and based on where it lands you get a price. So this is one of the application of uniform distribution, and you frequently come across. So also, do you remember that in one of my first lecture I told you that you can always discretize continuous distribution. Okay, so here is an example where you can break the continuous distribution in a discrete variable. Okay, for example, 0 to 30 degree I will make it up to 250 back. 30 to 60 degree I will say, okay, you got a price of Samsung M31, and so on. So this is a way of discretizing a continuous variable. Okay, so this is one example. Another example is, since you see that this is the standard uniform distribution and taking values from 0 to 1, also you know that probability is also varying from 0 to 1. So this is also in a sense like a probability. Okay, and using this I can create a coin. Okay, I will show you. This is a okay, let's come back to this. So this is a coin I have created, nothing very special about it, but you can also create it. This is just Excel file. Okay, so in Excel file I have created a coin. You just have to press to toss the coin. Like I am tossing, head has appeared, head, tail has appeared. Okay, tail, 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 head. So this is like a coin. Okay, so this coin is made using nothing but a uniform distribution. Okay, so this is another example I wanted to show you. So hope you like it. Let's get back. So this is all about uniform distribution. I would say a very simple distribution, simplest distribution, but yet powerful distribution. Okay, the power comes from usability in generating distribution from other generating data from other distribution. Okay, in that sense. So let's get back to the next. Yeah, normal distribution. So normal distribution is a very well known distribution. Okay, everybody knows that. So what is special about it? You will see that the special about is there that all the set of data that this variable can take, all the set of values that these variable can take are distributed in a sense that some of them the probability of occurrence of some of them is very high, and as away from how do I say that, some data points are less likely. Okay, so there are cluster of data points which are very likely, and as you move away from that clusters the data point becomes less likely. So that gives you a bell shaped curve. So I will give you an example what I mean by that. Okay, take for example heights of people in the world. Suppose this x represents heights of people in the world. You know what the average height would be, anything like 5.3 and something, right? But it is very rare to find a person with a height say like 11. Very rare. Also very rare to find shorter people, right? Like 2.5. It's very rare. So height of people, the characteristics of this variable is that some of the values are very likely, and as you move away from those values they become very less likely. Okay, so likelihood decreases as you move away from those cluster of data points. Same example is temperature of a room. If you observe the temperature of a room in your room over time, you will see that the on an average the value will be clustered. Okay, it will vary in a range. It will be very unlikely that it will be like how do you uh, say 44 degree, say 50 degree, very less likely, very less likely. Okay, in a similar way, like minus 5 degrees Celsius, very less likely. Okay, but 27 degrees Celsius, 25 degrees Celsius, 35 degrees Celsius, these are more likely. So basically this is nothing but the y values are nothing but a probability of occurrence, and x axis are the values that a variable can take. So the property of normal distribution is that, and you also be wondering why it is called normal distribution. Oh, right, so this is one of the question being asked in the IIM interview, why the normal distribution is called normal distribution. Simply because it is very normal to find some heights of people more commonly, right? For example, I said say 5.5, it is very likely to find those people, very normal to find these people, and very abnormal to find a person of 11.5 or say 2.5. So very less likely, and very abnormal to find, I would say. So in that sense I would say this is a normal distribution, because that is one of the characteristics of this distribution. Some data points are very likely, and as you move away from those data points, those becomes very less likely. Okay, and some becomes very rare. So this is a sense of normal distribution that is more important. Okay, and again this is what I wanted to convey in this lecture, and hope it helped you. If you have any doubts or if you have any other ideas, please comment on the link of this channel. Have a great day. Thank you.